So, you've been learning about hardware, and you've learned that hardware only understands binary. So in this video, we're going to take a look at binary numbers and how they work, more specifically, how to count in binary. So we're going to be doing our counting in a little text editor. It's pretty neat. We'll mention this a little more when we get to pseudocode and stuff later in the course. But it's free, but they take donations. But I'm going to go ahead and open that, and we'll be counting in here. But first, let's take a look at the concept of places. Now this may seem a little confusing at first, but don't worry. After we take a look at this, we'll get and do some counting, and then we'll come back to this, and then hopefully it'll make a lot more sense. But this is base 10. This is the normal counting that you're used to. So this is actually 237, whatever. It's called base 10 because you have 10 digits, 0 through 9. Okay, and you have places. The ones place, tens place, hundreds or hundredths place, depending on how you say that. And what happens is you go through all of the digits in this one first, 0 through 9, and once you get to 9, you go back to 0 and increase this one by 1, the tens place. And so that's how this works. Note that once you get to once you run out of digits in the ones place, you've got the tens place. That's 10 times 1. And then because you had 10 digits. And in the tens place, you'll also have 10 digits again. So once you get to the hundredths place, it's 10 times that. That's 100. Now it works exactly the same way in binary, except you only have 2 digits. So again, you start in the ones place. But once you get to 1, you've run out of digits. So then you move to the next place. You'll see that here very shortly. And that is the twos place. And once you run out there, you'll go to the fours or fourths place. Note that it's exactly the same way, except here each place is a multiple of 2. So 10 is 10 times 1, 100 is 10 times 10, and so on all the way through. And in binary, it's all multiples here of 2, or actually it's powers of 2. This is 10 to the 0, 10 to the first, 10 to the second, and so on. So you've got the same thing that happens in binary. You have 1, then you multiply by 2 to get 2. You multiply that by 2 to get 4, and multiply that by 2 to get 8, and then all the way through the rest of these. Okay, that's the concept of places. Now let's actually do some counting. And let me zoom in here a little bit so that it's clearer on the video. By the way, I'm doing this this zoom, I'll zoom out a tad bit, by holding down the control key and using my mouse. You can do that in a lot of programs to zoom in and out. So let's go back again and start with what we know. That's the base 10. And let's count to 10 just to show again. So, whoops, actually we don't want to start at 1. It's kind of a thing when you're the more you get into programming, the more you'll learn to start counting at 0. There are different reasons, and it will make, as you progress through the course, it will make a lot of sense why you start counting at 0 when you're a programmer. So let's start at 0, then 1, then 2, then 3, 4, 5, 6, 7, 8, 9. Now you may be asking, gee, I was, how many, very, very young when I learned to do this. Well, we're looking at how we do it in base 10 to make it more clear how it works in binary. More specifically here, we've run out of digits. We've run out of our 10 digits. So what comes next? Well, we start over. We go through the digits again there with 0, except now we add the place. We go to the 10ths place. But in the ones place, we go through the same sequence. We start going through all of our digits again. So 1, 2, you get the idea. So we're going to cycle through all of these. Now let's get to, just to emphasize this, what happens when you get to, say, like 99. Actually, let's put a little space here to make that clear. So you're at 99. So you have to cycle this, or this one, and then, but see, you've run out of digits here. So what happens there? Well, we know that one's going to go to 0, but we've run out of digits here as well, so we're going to have a 0 there, and then that's it, the 100ths place. Again, this seems simple, but let's see how that works when you've only got 2 digits. And we'll go back to our counting 0 through 10 here. Except we're going to do it this time in binary. So we start again at 0, simple enough. Okay, and oops. And our next digit is going to be 1. Okay. And then our next digit is going to be, well, we're out of digits because we've only got 2. So again, as this cycle started over, remember we ran out of digits here, we went back to 0 and did this, except we added a place. And that's exactly what we're going to do here. This is going to be 0, and we're going to add a place. Just like that. So we're going to add a place. And we're going to go through this 0, 1 cycle again. So now when we get to 3, it's going to, we're still going to have our 2's place. Oops. And then so we're starting over again. 0, 1, 0, 1. Again, though, now we've kind of, well, we've run out of digits here, run out of digits here. We're going to have to add another place. So as you're watching that, keep in mind that is the exact same thing that's going on here. We ran out of digits in both of these places. So now we have to add another place. So we're going to do the same thing here. Let's see. This one's going to have to be 0. And this one's going to have to be 0 because we've run out of digits. But now we're going to add a place. And that's exactly how you count in binary. So let's go through the rest of these. We're going to start over again. So we're still going to have this 1, and now see the pattern. We're going 0, 1, 0, 1, 0, 1. Just like in base 10, we go 0 through 9, and then we'll go to like 20, and then we'll start over again. It's the exact same thing. It's just that you only have 2 digits instead of 10 of them. Okay, so what's this one going to be? Okay, well, we're still here at 1, but we've run out of digits here. So that's going to go back to 0, and then this one will be 1, and then 0. Okay. Now here, this is pretty simple. We've got a digit for the ones place. So it'll be 1, 1, 1. and that is 111 is 7 in binary. Okay, for the next one, you can already see we're out of digits here, we're out of digits here, and we're out of digits here. So what's that going to be? We need to add a digit, or a place, excuse me, a place, and then all the rest of these are going to be zeros. Again, it's like this. It's going from 99 to 100, except in this case, it's like going from 999 to 1,000. You're adding a place. And in 9 then, just to go ahead and finish out through 12, see, we'll add 1. For 10, we're out of digits for this, so we increment the next place. And here we've got 1, 0, 1, 1, because we have a space here. And then for this one we have 1, let's see, this one's going to be 1, 1, so we're going to have to move this. These two will become 0, and then that is 1 like that. Because this one we're out of digits, it's going to go back to 0, but then we need to increment this place. We're out of digits because there's just 2. It goes back to 0. So then here we're not out of digits, it's going to be 1, and then this is still 1. If you want to think about it in addition, it's kind of like carrying the 1 when you do that. Now, I said that we would go back to our other diagram here, and hopefully it would make a whole lot more sense for you. And what we're going to look at when we go back to that diagram is this 7, which is 1, 1, 1, and then 8, which is 1 and 3 zeros. So let's look at these places here. Now you can see I've done some addition. I'll get to that in just a minute. But imagine this is 1, 1, 1, like our 7. This is 7, 1, 1, 1. So what we do is we add them. 1, 1, 1. We've got 1 in the 1's place, 1 in the 2's place, and 1 in the 4's place. So you can see if you add 1 plus 2 plus 4, you've got 7. Now if we go back very quickly, we'll see that 8 is 1 and 3 zeros. So looking at our places, that would be 1 and then these 3 zeros. Well, all we've got is the 8's, so that's just 8. And so that's how that works. Now, if you want to see a comparison of something a little bit bigger, this number as it appears on this graphic, this is actually 237 in binary. Now let's look at 237 in base 10. That is, we've got a 2 here, so it's 2 times 100 plus 3 in the tens place, 3 times 10, plus we've got 7 in the ones place, 7 times 1. And that, of course, equals 237. This is 237 in binary. We can look at this 1 in the 128's place, so that's 128. We've got 1 in the 64 place, plus 64. We've got 1 in 32's, there's 32, plus we don't have anything here in 16's, so we move on. We do have 1 in 8's, so plus 8, and then we have 1 in 4, plus 4. We don't have 1 in 2's, in the 2's place, so we don't add anything there, and we've got 1 in the 1's place, so then we add 1, and that comes out to 237. So hopefully this is all making a little bit more sense for you. Some folks kind of freak out about this, but that's the reason I went through all of that simple counting 0, 1, 2, 3, 4, 5, 6. Again, you note that you cycle through all of your digits and then you add a place and start cycling through the digits again. Except in binary, you only have 2 digits, but you can still do the exact same thing. Note here in the ones place where we've done our counting, it goes 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, all the way through. Well, if we were counting to who knows what number in base 10 in normal numbers, you're looking at, you would go 0 through 9, and then you'd start again 0, 1, 2, the next one would be 13, 14, all the way down through, and then you would hit 10, and then after 19 you'd hit 20, so then you would increment this one just like you incremented here. But then when you run out, you've got to increment here. So it works exactly the same way, except you only have 2 digits. But when you're looking at something really big, of course, you can always look and say, oh, okay, so this is this is the value of each one of these places, just like that. Just like in base 10, each one of these is worth 1. Each one of these is worth 10, 100, 1000. Same way, except here you either have it or you don't. It's not that you multiply by 7 or whatever. So that's the basics of how binary numbers work and how to count in binary. It's important that you have this rudimentary knowledge of how binary works if you're going to be a good programmer. This concludes another video for Introduction to Programming with C++, brought to you by LogiKomp. You can access the full course by going to the course homepage at logikomp.com/introcpp. While we are proud to offer this course free of cost to individuals, we do ask that if you continue to use the course, that you support its production and maintenance by making at least a small purchase from LogiKomp Domains and Hosting. You can pick up a custom domain, renewable annually, for around $10 at logikomp.com/hosting. Thank you.